Hello. Welcome to today's lesson on calculating acceleration. We will begin today's lesson by formalizing our understanding of acceleration using the equation. Average acceleration equals change in velocity divided by the time taken. We will then take time to understand the variables involved in this equation and the units of acceleration. Finally, we'll go over some worked examples to consolidate this new knowledge. So far, you have developed an intuitive understanding of acceleration. You already know that acceleration refers to how quickly the velocity of an object changes. Building on this understanding, we will now formalize our concept of acceleration using specific terms and formulae. This will advance our grasp of how objects move and interact under various forces. Let's get started. Average acceleration can be calculated using the formula. Average acceleration equals change in velocity divided by time taken. This equation allows us to determine how quickly an object's velocity changes over a certain period of time. To use this formula, we need to understand the two main variables involved. Change in velocity, delta v, is the difference between the final velocity and the initial velocity. It is represented as delta v equals v final minus v initial and is measured in meters per second, ms. Time taken, t, is the duration over which the velocity change occurs. It is measured in seconds, s. The unit of acceleration is meter per second squared. This unit indicates how much the velocity changes by every second. For instance, an acceleration of 1 meter per second squared means that every second, the velocity increases by 1 meter per second. Let's apply what we've learned to a few specific problems to consolidate our new knowledge on average acceleration. A motorcycle accelerates from a velocity of 5 meters per second to 25 meters per second in 4 seconds. What is its average acceleration? First, identify the initial and final velocities. The initial velocity is 5 meters per second and the final velocity is 25 meters per second. Then calculate the change in velocity. The change in velocity is final minus initial velocity, which is 25 meters per second minus 5 meters per second. This gives us a change of 20 meters per second. Next, identify the time taken for the motorcycle to accelerate, which is 4 seconds. Now we apply the formula we have just learnt. Average acceleration equals change in velocity over time. Substituting in 20 meters per second over 4 seconds, we get 5 meters per second squared. So, the motorcycle's average acceleration is 5 meters per second squared. A cyclist is slowing down. They go from a velocity of 15 meters per second to a complete stop, 0 meters per second, in 3 seconds. What is the average acceleration? Note this will be a negative value. First, identify the initial and final velocities. The initial velocity is 15 meters per second and the final velocity is 0 meters per second. Then calculate the change in velocity. This is final velocity minus initial velocity, which is 0 minus 15 meters per second. This gives us negative 15 meters per second, which is negative because the velocity is decreasing. The time taken to decelerate is 3 seconds. Now we apply the formula average acceleration equals change in velocity over time. Substituting in the values we get, average acceleration equals minus 15 over 3, which gives us minus 5. So the cyclist's average acceleration is minus 5 meters per second squared, indicating deceleration. A train accelerates from rest, 0 meters per second, to reach a velocity of 50 meters per second over a duration of 20 seconds. What is the train's average acceleration? Once again, we identify the initial and final velocities. The initial velocity is 0 meters per second, and the final velocity is 50 meters per second. Next, calculate the change in velocity, final velocity minus initial velocity. This is 50 minus 0, so 50 meters per second. The time taken is 20 seconds. Now, apply the formula average acceleration equals change in velocity over time. Substituting in the values we get, average acceleration equals 50 meters per second over 20 seconds, giving us 2.5 meters per second squared. So the train's average acceleration is 2.5 meters per second squared. In today's lesson, we delved into the concept of average acceleration. We formalized our understanding of acceleration using the equation. Average acceleration equals change in velocity divided by time taken. By mastering this formula and its application, we gained a deeper understanding of how objects move and interact under various forces in the physical world. Watch the rest of the GCSE physics course at Sophos Education.